to is that whenever we deploy the agent, it will learn and learn about each client respectively, but you have a lot of control at a global hierarchy level at the same time. So for Atomic here, for our first example, we'll click Manage on them, and you'll notice that the portal will silo itself to just Atomic. As soon as you click Manage on that organization, that's all that we're gonna see. Everything related to just this one tenant, and we get that glimpse of the simulation. So right on the screen, it's letting us know 7 days ago, there are about 54 things that popped up as a simulated deny. And you get to see the progression each step of the way. So 72-hour period, a 24-hour period, that gives you a nice understanding of what's transpiring there without you even diving into the audit. So my next click in most cases is typically hitting the computers page. And reason being, you'll get another example of that simulation, but in a bit more detail. Every computer individually, you can see how they're doing. So if there's one machine that's a little bit noisier than the most, we can spend the time on that. But we're looking pretty good. In the past 24 hours, everyone is respective to, well, as close to zero as we can get them. And now we can take a look in the exact audit. So the unified audit here is a really useful tool outside of just the audit review that we conduct and looking at the simulation. This is a great tool for you guys to leverage. It's super useful when it comes to tracking things down, figuring out what users are actually doing. You get to answer a lot of those questions without asking them. So the unified audit here, you have a layer of visibility that you might not be used to if you've ever remoted into a machine just to comb through thousands of rows of event logs. Our goal is to eliminate that, because if someone deletes a file and you have a ticket open to find that file, number one, it takes a lot of time to just figure out where the file was to begin with. So instead of you going through those hoops, you have this layer of visibility. So if anyone deleted a file today, you get to see that. You guys have 30 days worth of logs. It's a rolling 30-day logging period. So if anything was deleted at all, you know exactly who and what executed that action. So as a quick example here, we can tell that this user plugged in a USB and they're deleting all the pictures from that USB. It's a Canon camera. We can tell that much just based on that visibility, but you're never hunting and combing through event logs just to figure things like this out. But outside of just the forensic nature, you use the unified audit to simulate the full lockdown experience. So what I get to show you guys is this. If we were to secure Atomic and lock down every single thing in their environment today, we'll know exactly what ThreatLocker likes, what it would have blocked simply because of that. So that query is really simple. We can say, show us a policy action of any deny. And I typically group by path or hash at the beginning here. You'll see in a quick second exactly why, but this allows us to see exactly how the agent would interact with everything. So as of today, the things that we're denying inside of this environment are things we expect to block. So this is going to go down to policy control and best practices. We know something like Microsoft Edge should be able to run, so we allow it to. But what's never necessary is a browser, something like Edge, Chrome, Firefox, well, to be executing code. So if at any point in time an application like that steps out of its lane, we automatically deny it. But what we're looking at here is the simulation, right? We know that the machines are in learning mode. So the policy action is going to be a ring fencing restriction. So whenever we go live, we know exactly what the agent will do if this ever transpires. But because we're in this learning state, it was allowed to take place. So this is a simulated deny, a simulated ring fence item that we're actually looking to enforce. So we're not going to make any changes or adjust anything because that's the goal. We know that Google Chrome needs to run, but there's really some limited use cases out there that would ever require Chrome to have access to command prompt. So we enforce that block from the very beginning. And
Hmm.
that's the idea. Because of the logging now, we can actually say if we secured every machine inside of this network back on the 10th, first thing Monday morning, now we can see exactly what things the ThreatLocker agent didn't like, or, well, it would have blocked based on the policies that we had configured at that time. So going back to the 10th, the only other thing that's changed here is this one DLL.
To say.
And yep, so the funny thing here is that it's the K working directory and it's using a OneDrive lib.dll, but that DLL actually has nothing to do with Kaseya or Microsoft. Right, so that's where that visibility starts to make such a difference. You know from the very beginning that curl here is what was used to create the DLL, and then PowerShell was used to execute it. So you'll never be in a position where you have to question why something is popping up as a simulated block. The answers are always there. So to use this as an even better example, you'll have this view file history button here. So at any point in time, if someone opens an application, conducts a piece of behavior, you have the full logging of everything we've seen about that at your fingertips. So whenever you click that button, it might take just a little bit for the history to pop up, depending on how many times that thing is actually executed. But that's where the visibility makes all the difference. We know exactly how we interact with everything going on down to the millisecond. So this is what the simulation looks like before we enforce policies, before we cause any unnecessary friction. I know everyone in this chat is not looking forward to any extra tickets, so we don't create any. If there's something that is truly new and truly attempting to execute for the first time, that's exactly what we're designed to alert to you guys to and give you the ability to control it. So yeah, this is something new. We can tell based on the history here that it was pushed out to the machine on the 11th, and it's the very first time the agent saw it running. So we expect to see the simulated deny. It's by design. But what's cool about this learning process is this. While the agent sees a simulated deny take place, it will create a policy to make sure that piece of software, that behavior can run if you want it to. So whenever we're in the audit, this permit application button will kind of answer that question for you right away. It will tell you directly if the agent learned about that file, that piece of behavior or not, and how it profiled it. So this is where things become extremely useful. We know that you guys are Kaseya partners and you're using this from an automation perspective. And we had one computer that learned about this OneDrive lib.dll. So instead of us doing this process again for every single client that's inside of the portal, we get to do something very, very simple. Atomic here has already gotten the hard work done. It learned about that K working. Oh, if I could actually spell here, we'll give that one more go. I promise I'm awake. So we'll take that K working application that the agent created. It's doing this all on its own. So absolutely everything it learned about K working for Atomic, well, all those files are here. It will break that down all on its own. So if the first time the agent is seeing this file was yesterday, that's again by design. We expect to see the simulated deny, but this is how instantly gratifying that learning conversation is. As soon as it sees that transpire, it starts building in the policy control to make sure it's allowed to run if necessary. And that's the goal. So instead of us going through every client and revisiting the same exact piece of behavior, we get to do something like this. We can take this K working application and I'll select merge. So right from Atomic, this child organization that you guys have, we can take whatever was learned and move it up to the parent level. So I'll select this Avert Networks parent application and we can merge it to it. And that's it. We are really in the business of doing things like this once. So it doesn't matter which computer learns about it, it becomes mutually beneficial to absolutely everyone. And this is the quickest way to get that done. Before I click merge, though, what I want to show off is this. For Avert Network Services, you guys again have global policy control. So you'll notice we have Kaseya up here as well. So whenever we are building policies and making changes that can benefit absolutely everyone, we get to use that to our advantage. So we can merge this up to the global level, which is the Avert level, since you guys are the parent MSP in this case. And that allows us to have that policy control trickle down to Atomic and absolutely everyone else. And that's what it's really about. Again, before we flip these computers from that learning state that they're in and we start enforcing restrictions, this simulation here allows us to make sure what we're seeing actually makes sense. So that's it. We never lock down or flip these machines to secured without making sure the policies are configured in a way that's beneficial. And that is the review process in a nutshell. So from here, I'd be pretty comfortable with securing Atomic because of their simulation. Their auditing is really, really clean, and there's not much that's changing either. So we're in a pretty good place. So wanted to pause there, see if you guys had any questions on that piece.
Can you explain what ring fencing is? Because I
Yep.
know Anthony is new on here.
Okay, yep, and I'll dive into that for you right now. And just a second. And we will take a look at Atomic as this example. So ring fencing is a second layer of control that we offer every partner of ours. It is really the bread and butter of our security stack from a ThreatLocker perspective because it allows us to differentiate, well, the security conversation altogether. And I'll give you a few examples. So ring fencing, it allows us to implement best practices. There's a lot of things that we can do in all honesty in a no-brainer sense to make sure we're eliminating a lot of security issues. And we're going to shower you guys with those best practices from the beginning. There's no human intervention here. All of these ring fencing policies that we're looking at were created all on their own. And we'll run through a few examples just to make sure you're comfortable with the concept. And we'll pick on Microsoft quite a bit. And we'll start with the spool service. So, a quick question for you guys. How did you handle Print Nightmare when that popped up, really in just the space in general? Did you find yourself stopping print jobs or disconnecting access to the internet? What did that kind of look like for you guys?
We only really had one customer with print server that was um, in play. So we went and locked that customer's print server down. We followed just the best practices for allowing the correct. I have to go pull all the documentation. There was quite a bit of little things that we did there.
Okay.
Yeah, allowing print specified computers in for the print spooler and things like that. Trying to use Windows update that came out and then uninstall it immediately because it broke more than it fixed.
So. Right. And those are the things we want to eliminate. And ring fencing gives us a wonderful opportunity to do that. And it takes what Microsoft normally what we've had to deal with from a historical sense. They built Windows to be really, well, easy to use. So security was an afterthought in most cases. And this is a great example of that. We know as technicians that if there is a spool service, regardless if it's a print server or if it's just the spool service on the workstation, there is absolutely no reason at all why the spool service would be communicating to command line and executing code. So we never allow that to begin with. So you made such a great point there. You end up going through the phases where you're patching. The patch, thanks Microsoft, nukes a lot of things, and you're going through this back and forth. So with something like ring fencing, we get to say, well, this year, well, last year, I should say, wasn't the first time the spool service was compromised, and it won't be the last. We have Patch Tuesday for that very reason. So regardless of whatever vulnerability exists, there's something we completely understand as text, and is that the spool service should never be talking to command line. But to make things even simpler, this is my favorite aspect of ring fencing. There is not one use case out there that anyone can give me that would ever require the spool service to communicate to a server in Russia. So we never allow it to begin with. Why is the spool service capable of downloading malicious payloads? So this concept of ring fencing, it allows us to kill two birds, and it's well, really one. We always talk about this human element in security, and that comes down to the developers that create the software in the first place. If there are humans in the equation, there's always room for error, right? And that's what we're looking to eliminate. So it doesn't matter if any of these tools get compromised, they can only do what's necessary. And that's the goal. So the spool service, again, it will be compromised in the future, no questions about that. But even if that's the case, the spool service can't execute code and it can't download malicious payloads. So we get to mitigate against any vulnerability that kind of pops up that way. Another great example is something like Log4 that created a lot of unnecessary pressure. I'm sure it had you guys patching things left and right. One of my favorite examples with Log4 is the way Huntress actually used Minecraft to show off the exploit itself. So you're connecting to Minecraft, and all of a sudden, someone is executing remote shells on your machine. And we get to say, why is anything like that ever necessary? So it doesn't matter what the vulnerability is. You could deal with a vulnerability like Solo and Orion, like Exchange, like Log4. Ultimately, every vulnerability will do one of two things. It will either grant unnecessary access to your network or allow someone to remotely manipulate your tools. And ring fencing allows us to eliminate that altogether. If you take the Log4 example to the heart in this case, Log4 allows anyone to remotely execute code. So whether that's PowerShell, command prompt, C script, Redsurf32, they have full control, and at the system level for that matter. But what we get to say is this: you guys already have an understanding of how PowerShell should be used. And we have a nice understanding as well. One thing we know is that you never use PowerShell to manage your backups. So we would never give PowerShell the ability to encrypt or exfiltrate data like that. So that's something we get to cover and protect from day one. So if we're thinking about the kill chain of attacks now, if something like PowerShell is being weaponized, we see in many cases it's the thing used to download the ransomware. But you are already controlling exactly how PowerShell can speak to the internet. So we're mitigating against that again from day one. So it allows us to really simplify that security conversation. We know Atomic, there is no scripters here. And I know this because PowerShell doesn't have any exceptions. If PowerShell goes out over the internet, we log absolutely everything it does. So you have this understanding from the very beginning of exactly what that network needs, and we get to limit it to just that. So that's where ring fencing makes a big difference. You're never hoping the users are doing the right thing, and you're definitely not hoping the developers are doing the right thing. You already have an understanding of what's necessary, and that's all we allow. So my favorite example, and it's honestly the simplest one, I know that you guys conduct security awareness training. So with that in mind, you already have an understanding of who clicks those $50 gift cards, who wants to go shopping at GameStop. So instead of hoping those users are always doing the right thing, you get these two policies. And it becomes very simple. We manage Microsoft Office, meaning our team, we have a dedicated team that tracks all of its updates, all of its dependency changes. And because we do that for you, we understand exactly how Microsoft Office should work. And what we learned is that the only time anything in Office needs the ability to communicate to command line, schedule tasks, or any administrative tool, it's literally when you and your team are patching and installing Office with your automation. So we never allow anything else outside of that. What this type of policy will automatically stop, it will be those users that do this. I typically laugh and say, from before I've existed on this planet, this best practice has always been in place. And it's something so simple. We tell everyone to hover over links. Just that one step alone could eliminate so many threats. But we also wouldn't be in business if that was the case. So instead of hoping those users are always doing the right thing, we just enforce the policies. Funny enough, I had a prospect email me earlier today telling me and my ThreatLocker team to make sure we're not clicking on any links or any emails that were sent from him because he got phished. And this was the same person that told me that he's pretty confident that he wouldn't need something like this ring fencing example. And lo and behold, he clicked that link. And he's the most security conscious person inside of the company. So it always allows us to really reinforce that concept. You might even know that this is something malicious. You can accidentally click it on your phone or copying the link over and it still executes it. That's that layer of human error that we always talk about. And you get to protect against it from the very beginning. If it's an actual link, well, that makes sense for something like Office to open legitimate links. But why is Outlook and Word executing code? That's never necessary. So we never allow it. So that's really a crash course on ring fencing. It's all about control. You guys already have an understanding of what should happen, and we get to enforce that from the very beginning. Any questions on that ring fencing side of the house?
No, no questions. I think that's one of the big things to prevent. Yeah, that's one of the really cool tool that you guys have. ThreatLocker.
And yeah, in the extreme use cases where it makes a big difference, it really comes down to administrators. So we typically show off a ring fencing example, and it's based on the attack that took down the pipeline. So in that scenario, an administrator was compromised. And in most cases, if you're a domain admin and your creds are stolen, those are the keys to the kingdom. But what we get to say is, even if you're an administrator and you can run something at the system level or with administrative rights, those tools can only do the things that are necessary. So I typically use PowerShell as an example here. I have my policies built around PowerShell, so it can talk to my ThreatLocker API, it can handle that patching. But just because PowerShell is communicating with something like Google doesn't mean it's necessary. So we never allow it. In a lot of cases, exfiltration is allowed to happen because Dropbox, OneDrive, SharePoint, they're all legitimate domains. They're not flagged as anything malicious at all. And attackers just use that. They know it's legitimate, so that behavior is just allowed to take place. And that's exactly where we paint such a good picture. So from here, ring fencing, it's all about restrictions, right? And that's one of the reasons why we conduct the review in this case. And the idea is that if any of these policies are too restrictive out of the box, we get to see the simulated denies tied to it. And before we enforce those policies, we can make sure we're not being too restrictive. And that's really the goal. So that's a good example of what the audit review process looks like at a high level. Don't worry about trying to understand and capture every single thing today. That's why we have these rolling meetings. We can always reinforce this. But to shift gears just a little bit, we'll take a look at a client that is already secured. And for this one, we will take a look at Atlas. So Atlas was locked down on our last meeting. And from there, we actually have some hard denies at this point. So things that were actually blocked by the ThreatLocker agent. One of the reasons why I'd like to start from the computers page, it's because when we're at this org level, it's not giving you an idea of who we're denying. So you get to answer that right away. And just taking a scroll here, you can see the majority of the machines are looking good, with these two desktops just having a few files blocked. And we can take a direct look at them. This will be pretty cool. Since the naming convention for the machine is pretty standard, we can take a look at both of these desktops at once. So I'll grab this portion of their name and I'll pop right into the unified audit and I'll say, show me everything going on with those desktop machines. And because the simulated denies track a week, I'll go back to the 5th and I'll say if there was anything blocked at all, I'd like to know about it exactly. And this is the post review process. In most cases, you're not spending a lot of time doing this, but we get to see exactly what popped up. So we'll go back to the 5th. And I think we covered this on the last meeting, but this will be a good example. So you'll notice the red denies, the red ring fenced versus the green one. So that color coding is going to let you know whether or not they're in that simulated state right away. So starting with this one, this is a hard deny. And this is an interesting one because you'll notice the process in this case is Internet Explorer. So to properly read this item in the unified audit, Internet Explorer is attempting to read this file, this vendor.dll. What's interesting about this is that Dr. Hamer here is using Internet Explorer to read files on a DVD. That's a little not sketchy, but why Internet Explorer? And I understand why this ring fencing restriction is in place. And it's because, well, Internet Explorer is about to reach its end of life. So, in all honesty, guys, this is probably the most restrictive policy we have. It is the only browser that we do not allow to have read and write access to files out of the box. And it's because it's IE. So in most cases, what I normally suggest, if I was supposed to have my way, we'd actually stop Internet Explorer from being able to run at all. I hate this thing. So that's my normal recommendation. We just say to Dr. Hammer, try to use a different browser. But in a lot of cases, medical facilities like this, they run some really terrible line of business tools that might need Internet Explorer to have
Yeah.
a bit more access. So we can't block it, unfortunately. So what we get to do is something simple. If we know that IE needs to have a bit more access inside of the environment, we can allow that. So you'll notice there's an add to policy option here, and that's exactly what we get to do. We can be less restrictive. We can allow it to do a bit more. We have that type of control over IE and really everything else. So it looks like he's reading disk with Internet Explorer, and his D drive is where his disk populate. So we can give him that ability to have Internet Explorer read the D drive very simply, and that kind of eliminates it altogether. And that would be a quick example of what the post lockdown process looks like. Again, we try to make sure we're not being too restrictive in any capacity, and it just allows us to eliminate issues altogether like that. And we have two more examples that we'll run through. This is one of my favorites here because McAfee, it's it's like a virus in itself. I hate to say it, but that's just the hard truth there. It's so hard to uninstall. And what's even funnier about this example, this is McAfee coming from the Windows App Store. So I'm pretty sure, are you guys using McAfee at all from a standardized perspective with
No,
AV?
we have Sentinel One, Huntress, and you guys for our three security products.
Perfect. So I'm pretty comfortable with this guy being blocked, but that's it. It's there installed and it's trying to run on its own. So we're pretty comfortable with that not being able to execute. So we have one example here that we can actually work on right now. And this is going to be a quick example of a driver DLL being denied. And this is going to go back to why we like to use global policies. And if I click permit application here, what will typically happen is that we don't have a match because it's something new. We've never learned about this before. So there's no novo definition that lives here for Atlas. But what I know is that we have a global, I believe we do, we have a global Lenovo policy that allows it to run for absolutely everyone. So what I can do here is this. If we know that this file is changing, that's exactly why it's popping up as a deny. My job here as your engineer is really to help you guys become a bit more comfortable with creating rules and stopping things like this from popping up. And this is what this process would look like. Because we have a Lenovo application at the parent level, we get to use that. It's already a global policy. So again, like the first example we had with K working, instead of us doing this for every single client moving forward, we have this ability to get it done once and have it benefit absolutely everyone. So from my experience, I know that Lenovo, they're pretty good with signing their files, but they just didn't sign this one. So instead of building a rule on its cert or just restricting this file to run based on its hash, which we know will change, we can add in a rule like this. So it allows us to make sure that from a management perspective, you and the team are never micromanaging files. That's never our intention. If we know that something is supposed to run, well, regardless of how many times it changes, we have full policy control over that. So we get to build a rule like that once, and we never have to touch that a second time. And that's one of the most important things I like to communicate. I am very much in the business of doing things once. If something pops up as a deny one time, that's the only thing we need to make sure we have some good policies in place. And that's the goal. So we get that exception taken care of. This has been a full week worth of lockdowns for Atlas, and we're looking really good. And that review allows us to make sure that the policies we have in place are just even more beneficial. So we already have that Lenovo policy at the global level. We add that rule in, and that benefits absolutely everyone. And those will be a few quick examples of what the initial lockdown process looks like, what the post lockdown process looks like. And that's really the goal. You'll notice you guys didn't get a request for any of this from Atlas. And it's in most cases it's because, well, Dr. Hammer or the users there don't need it in reality. So something we typically see is, well, because of productivity in this case, users don't have that ability to just install garbage. You don't get any tickets to clean up garbage. And that's exactly what we're trying to make sure we're doing from start to finish. If we eliminate, well, the user's ability to screw up the environment, there's less tickets that get generated because of that. And that's the real goal. Because you have so much control of the network now, it's never a matter of if something is necessary, you know that every step of the way. So as of right now, your global workstations list looks a bit like this. And the next step, the next thing that I had to review for you guys is this very fact. We did an internal deployment to your team and we learned a lot. It actually created almost 400 policies based on the software you and the team use. And this is a gold mine, meaning something like this. If we learned about 7-zip on your workstations, is there any reason you would tell a client no, they can't run 7-zip? Would you deny someone requesting access to 7-zip in the future?
Hey God, this isn't a very fair assessment because I installed this on a personal computer just to see what all it would pick up. There's no way in hell I'm going to approve Steam on our clients' computers, right? And that should be showing up on this. There are certain things that are going to show up here that absolutely should not, simply because I put this on a personal gaming laptop. I just wanted to see what all it was going to pick up, just to see how good you guys really are, right?
Okay.
So I don't want to say anything that's good at Avert is going to be used
Good
anywhere
everywhere
else out there, right?
Yep.
Until I've gone through and deleted anything that says Alienware or Steam or anything like that. So
and
let's.
and that's a great thought there, but that's the right idea. Because of the learning we were able to do, anything that you and the team feel like becomes mutually beneficial, not just for the team internally but for any clients, what we get to say is this: you never have to force another client to relearn OneDrive or to relearn 7-zip or something like Keeper Password Manager, because we already did the due diligence, learned about your environment, and went through the POC. We get to make sure we make the most of that. So something like Veeam here. If we know that Veeam is supposed to be running on workstations, we get to forego any blocks tied to something like Veeam to begin with. you guys have the ability to move policies up and down that hierarchy as you determine is necessary, and that's where the time savings really come in. Again, we're really about doing things once, and you have that global policy management to make sure all of your automation, the tools you're standardizing, are just approved from the very beginning. So becomes a really good example. I would say we want to make sure Veeam can execute everywhere that it needs to, so you're not revisiting that a second or third time. So what I typically say is this: if you guys are standardizing against any vendors, let's say hypothetically you resell Lenovo's to your clients, it would make a lot of sense for us to have those Lenovo policies at a global workstations level. So that is some due diligence we can put in. You're never restricted to a deadline or a certain time frame. You'll always be able to manage that global whitelist, but it's something we can do here and there just to make sure we're cleaning up the audits even more. Yeah, so Teams here becomes a really good example. You probably wouldn't say no to anyone attempting to install Teams at all. So let's forego a request for something like Teams from the beginning because of that global level of approval that you have access to. And we're at the 44-minute mark. That's really it at a high level that we can cover with the review and the post lockdown. So we have about 15 minutes left that we can just use for any questions, anything that you guys want to dive into a bit more on.
No, but our next week's session, I'm gonna want to focus on a specific customer, and that's Pioneer Fasteners. I want to get this deployed. It's been in learning mode for them for some time now. Theirs is going to be critical that I don't screw it up from the beginning. They're one of those customers that loses a substantial amount of money per hour when they're down, and they have a in-house um, like an EHR system. It does, all of it's their world, right? If the DDI that if that goes down for any reason, and then it has agents on its computers. I am drawing a blank on the name off the top of my head, but this is one I'm about to focus on and get fully deployed for these guys. And I want to make sure that we're not interrupting them. Yeah.
And yep, so Ty let me know about DDI when we first deployed to them. So we did a little bit of work about a month ago, if I'm not mistaken, to clean up things related to DDI. You'll notice that it is the only policy that exists at the organizational level, and that's by design because nothing gets learned at this level automatically. Everything that gets learned hits the workstations and servers group. So we did a little bit of cleanup to move that DDI policy to the organizational level. So it'll cover all servers and workstations for Pioneer. So we're in a good place there. So we have about 14 minutes. We can do a quick review on them just at a high level, but this is the typical cadence. Depending on the goal of the call, it can always be twofold. We can cover training and the audits at the same time. It allows us to kill those two birds with every session we have. So for next week, since Pioneer is going to be the focus, the typical scenario will be this. If we were supposed to secure every endpoint in Pioneer back on the 5th of January, we can see exactly whether or not we have to make any changes, tweaks, and that this is where the simulation becomes so powerful and useful. We get to see explicitly everything that's going on. So going back to the 5th, we have 49 simulated denies, and that's pretty good. At a glance, just scrolling up and down, you'll notice there's nothing here tied to DDI. One interesting one that's popping up is actually Firefox here, and it is most likely because we don't have this Firefox policy at the global level. So this is what I was mentioning. Something like Firefox is a ThreatLocker built in. We know exactly what Firefox is. We manage it for you on your behalf. So you'll realize it matches that from the very beginning. What this global policy list allows us to do is clean up the audit simulation. So in essence, if we had that Firefox policy that's right here, if this was applied at this global workstations level from the very beginning, that means we would never see any simulated denies tied to Firefox at all. So that's why that global policy list becomes so useful. It just eliminates noise from the simulation because of that. Firefox is something we know from day one. We're really comfortable with it running. So if you have that policy in place, it equates to less simulated denies. And that's the end goal. We want to make sure before we lock down, we have the policies in place covering everything that should be running. And that's the idea. So you'll notice the uninstall helper. When I approved that Firefox policy at the global level, I made sure the helper was also taken care of. And that's the idea. So because Firefox is now approved at the global workstations level, let's do this. We'll eliminate anything tied to Firefox from the simulation. So removing the simulated denies tied to Firefox, we're down to 38. And again, this allows us to validate every step of the way how the agent is interacting with that client. And that's really the goal. So we'll be able to dive into this a bit more on the next call, but just even as an example here, you'll notice it seems like you guys patched this machine. So this is a good example. Perfect. Windows 10 added in on the 7th. So yeah, Windows updates coming down, they get covered. But one thing to note about the way the agent audits, if you're patching a machine from one build to another, we have what we call core files. So every computer has the respective core files to its build of Windows. And as you're updating and downloading those core files, what we're essentially showing you here is that this is another build that's running on the machine before it's been patched. It's not something we stop, but from a software perspective, it is programmatically designed to still show you the simulation. But just rest assured, that is exactly why we have this Windows policy here. And we'll do Windows update. And every computer gets this policy applied. So Pioneer fasteners, they are looking really good. And we get to show you the simulation a bit more on the next call. But that's the general idea. Every step of the way, we get to make sure those things we need are taken care of. And we did a bit of work on DDI earlier on, and that puts us in a good position. The only thing that's kind of left over with Pioneer, I guess they had two different locations or organization names at one point, so it ended up creating a duplicate org. And we moved the devices over already, so the last thing to do is just delete the duplicate company.
Yeah, I think one was manually created and the other was created via our RMM.
The RMM. Okay. Yep. So I moved the devices over already because I knew Pioneer was a bit higher on your priority. So they've all been learning in the same place for a nice period of time there. So yeah, we're looking set. I have my notes for our call next week. I'll be diving into Pioneer on my own just to make sure things are making sense as we progress, and we get to take another look at them on next Wednesday.
Cool.
So yeah, we're looking pretty good, Tim. Let's see here. Oh, the last thing. This piece is also important. So whenever we create global policies and we add global policies on, they do not deploy automatically. So for us to field global policies across all clients, you'll have to hit this organizations page. You don't have to select all, technically. You can hit deploy and then deploy all. So this will make sure every client and every computer feels those global policies from top to bottom. And that is the last thing that I had.
Cool.
Awesome.
Quick question. Have you guys engaged with our cyber heroes at all? Any feedback there from?
I've only done the chat stuff because I was trying to hide the
Trey
icon, the tray icon, and it was like really tiny, so I couldn't see it. Then I finally figured out how to get it onto a bigger Windows screen on the web browser. And I just forgot the parentheses around the word hide.
Okay, that makes sense.
And and so I was just trying to hide it on one of the clients and try it out. I uploaded our logo brand just to our Avert account, but I'm gonna have to get that fixed and get it down to the right size so it looks a lot better than what it did. It looks blurry now.
Okay, yep, and the team can always help out with that. And I guess that's the last thing that I wanted to really cover today. So we have this theoretical wheel of support, right? In one case, there's me as your engineer. Every week we'll have those sessions to cover any questions, any use cases that kind of pop up. You'll have the university as a reinforcement of the things we cover. Don't ever feel like you have to go through those university courses, but we recommend it because it'll again just reinforce the things we discuss. And then the cyber heroes. So if at any point in time you guys have a question, our rule of thumb is 3 minutes. If it's taking you longer than 3 minutes, and I know that's hard, that's a hard pill to swallow, as techs tend to spend a lot of time just trying to figure things out, but the goal there is just to make sure you're not, well, getting frustrated or even wasting your time. Your time is so valuable. So just reach out to the team if you have any questions at all. We really look at those support engagements as extended training. So don't hesitate to give the team a shout.
Cool.
And outside of that, I feel like we are all set for next week.
Hey, Colin, I didn't catch. Did you, by chance, Ben stepped away from his desk and he's going to schedule you guys' next audit review. But did you already ask for a time, or do we need to
No,
figure
I
out
didn't.
what time?
Yeah,
Okay.
we should figure out what time works best. Yeah, we don't have one locked in for next week as of yet.
All right, guys, I'll leave that up to you guys to say. I'll pass along to Ben so he knows when to schedule it. But as far as Colin's calendar, I'm pulling it up right now to check his availability. As you guys know, he's a pretty booked guy. The 19th does have and you guys being in Central Time, a 4 p.m. available on Wednesday. Or Thursday next week is actually pretty wide open. He's got your time, 8, 9, 10, 11 a.m., and then 12 and 2 p.m.
What day was that?
That was Thursday.
The 20th.
Yep.
What do you guys think? 4 o'clock? Usually, it's really hard. You just got to put it on the calendar and.
Yeah, later meetings tend to get missed more than earlier meetings because it gives too much chance in the day for customers to have something go wrong and tie us up. Just historically, from what I've seen, meetings earlier in the day are always easier to make for me.
Yeah, it helps because every time we try to do a 4 o'clock, I'm either driving or something.
Yeah, or somebody's broken something somewhere and we're having to respond to some
This-
emergency.
It's kind of
Do